Your bones are a secret gland, not a metaphor. Somewhere inside the pale core of your skeleton, cells are manufacturing a hormone and releasing it into your bloodstream. Right now, as you sit here, it travels through your body and reaches your brain. It reaches your pancreas. It reaches organs that have nothing to do with holding you upright, and everything to do with how sharp your mind feels, how much energy you carry through the day, and how quickly or how slowly you age. For most of medical history, no one thought to look for this. Bone was framework, a stack of dense dead calcium holding up the parts of the body considered more interesting. The brain, the heart, the muscle. In 1543, the anatomist Andreas Vesalius published his great work on the human skeleton, mapping every bone in extraordinary obsessive detail. Even he described bone purely as structure, scaffolding, beautifully rendered, but scaffolding all the same. That story sat unquestioned for 4 centuries. Deep inside every bone in your body live cells called osteoblasts, the builders responsible for laying down new bone tissue. Working against them in a constant quiet negotiation are cells called osteoclasts, which break old bone down and clear it away. Together, this pair rebuilds your entire skeleton in slow, overlapping cycles across your whole life. Meaning the bones in your body today are not materially the same bones you had a decade ago. For years, scientists watched the builders build and assumed that was their only function. Quietly manufacturing structure, nothing more. Then in 2007, a paper published in the journal Cell overturned that assumption completely. A research team led by geneticist Gerard Carcenti at Columbia University discovered that osteoblasts do something no one expected. They secrete a small protein directly into the blood, a true hormone called Osteocalcin. And that hormone travels the body issuing instructions to organs far removed from the skeleton. Instructions like, release more insulin. Instructions like, produce more testosterone. Instructions, later research from the same laboratory would show, that reach directly into the brain and shape memory itself. Instructions, a further study would reveal, that surge into the bloodstream within moments of real danger. Faster, in fact, than adrenaline, suggesting your skeleton plays a hidden role in how your whole body responds to acute stress. Bone, it turned out, was not scaffolding at all. Bone was a gland, an endocrine organ, the term for any tissue that releases hormones straight into the bloodstream to control something happening elsewhere in the body. The thyroid is an endocrine organ. The adrenal glands are endocrine organs. And now, sitting quietly in your legs, your spine, your skull, so is your skeleton. Here is where it gets stranger. Long before Carcenti's laboratory ran a single experiment, an entirely different tradition had already made bone central to the story of vitality. In the classical medicine of India, recorded in a text called the Charaka Samhita nearly 2,000 years ago, the body is described as built from 7 progressive layers of tissue called dhatus. Each dhatu is refined from the one before it in sequence. Plasma becomes blood. Blood becomes muscle. Muscle becomes fat. Fat becomes bone. Bone tissue, astidhatu, sits deep in that sequence, 5th of the 7. Not decorative, not incidental. The ancient physicians placed it among the deepest, most concentrated tissues in the body, the layer from which marrow maja is nourished, and from marrow, they taught, comes ojas, a word with no clean English translation, but usually rendered as something close to vital reserve or the distilled essence of stored life force, the last and finest thing the body produces when everything beneath it is functioning well. The underlying idea running beneath centuries of this medicine, bone was never mere structure. Bone was where deep vitality pooled and radiated outward from. It is worth sitting with why. In a body without imaging equipment, without a way to measure a hormone in blood, the physicians of this tradition still notice something true. That brittle, depleted bones seem to travel hand in hand with a person's vitality fading elsewhere. Memory dimming, energy thinning, recovery slowing. They had no mechanism to point to. They simply observed the pattern and built an entire physiology around trusting it. This is also in part why so many devotional movement practices place the body low, again and again, in contact with the ground. A forehead touch to the floor. Palms pressed flat beneath the shoulders. Full prostration, repeated as a form of reverence. Read one way, it is a gesture of humility. Read another way, through the lens of astidhatu, It is the body returning its own weight to the earth, over and over, as though some part of the tradition already understood that this contact was doing something, even without a word for what. Two systems then, separated by 2,000 years, a language barrier, and completely different methods. One measuring hormone levels in a laboratory in New York, one reading tissue and pulse in ancient northern India. And they arrived independently at strikingly similar conclusions. That something essential to your health, your energy, even your mind, lives inside your bones. And it is not merely structural. So what does osteocalcin actually do once it leaves the skeleton? Carcenti's follow-up research, published in the years after that first 2007 paper, began mapping the hormone's reach in detail. Osteocalcin travels to the pancreas, where it appears to encourage the release of insulin, the hormone that clears sugar from your blood, meaning your bones are quietly involved in how your body manages energy from food. It travels to reproductive tissue, where studies from his lab linked it to testosterone production in males. And in a further study from the same research group, published in the journal Cell Metabolism, older mice given osteocalcin showed measurable improvements in memory. Performing learning tasks closer to the level of much younger mice than their own age would predict. Read that again. A hormone made in bone, restoring memory in an aging brain. There is a further piece to this, and it matters for what comes later. The same research group found that osteocalcin does not simply drift out of bone at a steady, constant rate. It rises sharply during physical activity. When muscle contracts under load, it appears to send its own signal back to the skeleton. A kind of conversation between the two tissues. And the skeleton responds by releasing more of the hormone into the blood. Movement, in other words, doesn't just burn energy. It appears to be one of the ways your body asks bone to speak. This is not folklore. This is peer-reviewed endocrinology, sitting quietly in journals most people never open. And researchers have also found that bone activity itself is not flat or constant. It rises and falls across the day and night in its own rhythm, part of the same internal clock that governs your sleep and your other hormones. Your skeleton, it turns out, keeps time, which raises the obvious question. If your skeleton is capable of producing something this powerful, why does its output decline with age? Bone density in most people rises through childhood and adolescence, peaks sometime in early adulthood, and then begins a slow, gradual decline for the rest of life. Fewer osteoblasts building, more osteoclasts clearing away, the balance quietly tipping year over year. And if osteoblasts are the source of this hormone, then a slower, quieter skeleton is very likely a skeleton producing less of it, which may be part of why memory, energy, and recovery so often seem to dim together in the same decades, as though they were never separate systems to begin with. So, can you do anything to encourage it? Here is the counterintuitive part. Most people, once they hear the phrase bone health, picture stillness and protection. Move gently, sit carefully. Take a calcium supplement and let the mineral do the work quietly in the background. That instinct is not wrong for avoiding injury in the short term. But it is almost the opposite of what actually switches osteoblasts on for the long term. Bone is a tissue that responds to demand. Osteoblasts are activated by mechanical stress, the physical force of impact, of load, of your own body weight pressing down through your skeleton against gravity. Bone that is never asked to bear weight, never asked to absorb a footstep or a landing or resistance, has little reason to stay active, let alone manufacture hormones. This is precisely why extended bed rest or time spent in zero gravity causes measurable bone loss within weeks, even in perfectly healthy people. It is also why, decades into researching osteoporosis, modern medicine eventually arrived at the same prescription for aging bone that it once feared. Not less impact, but more carefully, progressively, and consistently applied. The skeleton is listening for a signal, and the signal is pressure. Now look back at what the old yogic and hatha traditions actually asked of the body. Standing postures held for long, deliberate breaths, weight driven down through the heels and the base of the spine, sun salutations repeated in rounds, the body's weight landing back into the ground again and again. Prostrations, performed hundreds of times in some devotional practices, the body lowering and rising against gravity without pause. None of this was framed in the old texts as being about muscle, The way a modern gym class might describe it, it was framed as grounding, as waking the base of the body. Practices recorded in texts like the 15th century Hatha Yoga Pradipika describe disciplined, repeated movement as a way of purifying and strengthening the body's deeper tissues. A language that, translated into modern physiology, describes almost exactly what is now called mechanical loading. They didn't have the word osteoblast. They didn't have the word osteocalcin, but somehow across an ocean in 1,000 years, they built entire physical practices around the one thing modern endocrinology now confirms actually switches this gland on. So here is the practice. Small enough to do tonight before you sleep. Stand barefoot, feet hip-width apart, weight spread evenly across both feet. This is Tadasana, mountain pose in the old language. Deceptively simple, deceptively still. Let your spine lengthen upward as though a thread were drawn gently through the crown of your head. Breathe in here, slow and full, and feel your weight settle evenly through both heels. Then, on the exhale, rise slowly onto the balls of your feet. Just an inch or two, and let your heels drop back down to the floor, not a stomp. A controlled drop, letting gravity do the work, letting the impact travel up through your heels, your shins, your hips, your spine. Repeat this 10 to 15 times, slow and deliberate, breathing with each rise and fall. Rest for a few breaths, then do one more round of 10. That small, repeated jolt is a mechanical signal, the same category of signal that, according to the research from Carcenti's laboratory, tells the osteoblasts buried in your skeleton that they are needed. It takes less than 2 minutes. No equipment, no supplement. Just your own weight, return to the earth on purpose. When the second round is finished, stand still for one final breath. Feel your heels flat and grounded. Feel the quiet, structural weight of you, held up by something you were taught to think of as inert. It is not inert. It never was. Do this most evenings and you are not performing a stretch. You are, according to the biology now sitting in the scientific record, asking a gland to wake up. A gland the old teachers already sensed was there, long before anyone had a microscope fine enough to prove it. Your bones were never just scaffolding, quietly holding up the more interesting parts of you. Tonight, with every grounded step, every deliberate heel dropped back to the earth, you are speaking directly to a gland you didn't know you had. And if the sages and the scientists are both right, it is listening.